In this unit, we've looked at writing expressions. We've looked at how to substitute for variables in expressions and find the unknown. We've also looked at the patterns and relationships between expressions and the inputs and outputs, and being able to graph an expression. Last week we looked at writing equations, and this week we're going to be looking at solving equations using algebra tiles. Now, solving equations, when we're solving an algebraic equation, the idea is to get the variable by itself, because the variable is what we're trying to solve for. We're trying to find out the unknown. In this case, it's k. You may remember 5k plus 2 was in one of our earlier videos. The difference here is that it now equals something. It is now an equation because 5k plus 2 equals 12. To do that, to get the k by itself, we need to remove any constants. In this case, it's a 2. And any numerical coefficients, and in this case, it's a 5, that may be attached to the variable. Eventually, when solving an equation, all we want to have is k or n or whatever your variable is equal to something. So instead of 5k plus 2 equals 12, we should have k equals something. So looking at that, again, right now I've got an equation up there, n plus 5 equals 9. We're going to do this using algebra tiles. We used reds and yellows back in Unit 2. So we're going to use that again today, and we're going to set up our equation like it was with algebra tiles. So we're going to bring 1n, because we only have 1n here, and we have 5, so plus 5, 2, 3, 4, 5. And then we have 9 over here, 3, 4, and then I'm just going to make copies of this and bring them over here as well. Okay, so if we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. N plus 5 equals 9. And we're going to use, just like we did with integers, we're going to cancel tiles out on either side of the equal sign. The equal sign is kind of like a teeter-totter or a seesaw. It has to balance out on either side. So n plus 5 is equal to 9. So whatever replaces n has to make plus 5 equal to 9. So this time, it's not about positives and negatives. It'll be doing one-to-one canceling. So if I have 5 individual ones over here, 1, 2, 3, 4, 5, I'm going to cancel all 5 of those out. And I'm going to do that as one-to-one to the other side. So if I canceled 5 on one side, I have to cancel 5 over on the other side. What I do to one side, I have to do to the other in an equation. So if there's 5 and there's 5, I have to cancel them out. So now what I've got left is I have my n, and I have these 4 left over on this side. So if I look at it, n is equal to 4. And then we can test that. If I was to substitute the 4 in for the n, 4 plus 5 is 9. Let's try that again with a different equation. So now I have 3n plus 4 equals 16, and the same thing like we did before, just like we did with integers, we're going to cancel tiles out on either side of the equal sign. So we're going to set this up first. So 3n, 1, 2, 3. There's 3 n's, and then I'm going to bring over 4 individual tiles. So now I have 3n plus 4. And now what I'm going to do is I'm going to model my 16 over on that side. There's 8. And there's 12. And there's 16. Okay, so now we have 1, 2, 3 n's plus 4 equals 16. 4, 8, 12, 16. And as before, we're going to start with our positive. It's kind of like doing reverse BEDMAS. Instead of doing your multiplication and your division first, because you're taking things away, you're going to start at the other end with your subtraction and your addition. So we have addition here. We're going to start by canceling out any individuals or our constants. So there's 2, there's 3, and there's 4. So we've canceled 4 over here, which means we have to cancel 4 over on the other side as well, which we do to what we do to one side, we have to do it to the other. Okay, so we canceled 4 on the left, we canceled 4 on the right. Now we're left with the 3 n's, and that leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now 3n equals 12. So if we have 3 n's over here, that means we have to break what's left down into 3 groups over here. And if we look at it, that gives us one group of 3, or one group of 4, a second group of 4, and a third group of 4. So 3 n's, 3 groups of 4. That means that each n is equal to 4. So if I were to replace a 4 in here, I go back to BEDMAS. 3 times 4 is 12, plus 4 is 16. So it balances. 3 n's plus 4 equals 16. I canceled out my four constants. I took 4 constants away from the other side. That left me with 3n equals 12. And then I have 3 n's here, so I divided this side up into 3 groups. And when I divide 12 by 3, I get 4. That means that each n is equal to 4. So I replaced it up here to check. Replace n with 4. 3 times 4 is 12, plus the 4 is 16. I'd like you to give this practice question a try using algebra tiles. Solve for the variable. 4n plus 7 equals 11. I do want you to draw out n's and individual tiles for the 7 and the 11. 4n plus 7 equals 11. Solve that using algebra tiles, please.